Welcome to the RTF tutorial. This is Fatih, and today we will go over the Runtime Fabric installation over the Azure Kubernetes and deploy a Hello World application over there. I assume you already chosen the RTF on Self-managed Kubernetes, so I will not be getting into the details of what RTF is and why or when some enterprise should use it. Our agenda today is MuleSoft deployment options, what is the runtime fabric, prerequisites, creating the cluster over the AKS, creating the RTF on Anypoint platform, installing RTF, configure RTF ingress controllers, and deploying a Mule application. So, what are our deployment options with MuleSoft? First, the cloud app. As we all aware, it is fully managed by the MuleSoft. The second solution deployment option is on-prem, which you are responsible for all the infrastructure. The third one is the topic that we will be going over today, which is Anypoint Runtime Fabric. And the last one, private cloud edition, where you manage everything about the Mule, including the control plane. So, what is Anypoint Runtime Fabric? Anypoint Runtime Fabric is a container service that allows you to run Mule applications, composite APIs, and API gateways across any environment with centralized management via Anypoint platform. So it's basically bring your own Kubernetes. There are two management options for the Anypoint Runtime Fabric. First one, which is we are going over today, is the Runtime Fabric on Self-managed Kubernetes. This is a version of Runtime Fabric that you install on an existing Kubernetes environment that you operate and manage. This version supports Amazon Elastic Kubernetes, Azure Kubernetes Services, and Google Kubernetes Engine. And the second option is the Runtime Fabric on virtual machines or bare metals. This is a version of Runtime Fabric where MuleSoft provides required software infrastructure components, including Docker and Kubernetes. So you install this version on virtual machines or bare metals that you operate and manage. So a simple representation of the Runtime Fabric architecture is, as you can see, the runtimes itself is managed by the MuleSoft, but the Kubernetes and the infrastructure over it, with like the network, the nodes, etc., should be managed by your Kubernetes specialist. Shared responsibility is kind of important because MuleSoft will not obviously will support, but the responsibility over the Kubernetes itself, ingress controllers, node pools, disk network, etc., these are on the customers. So before going to the RTF, customers need to acknowledge that these shared responsibilities, and they should have a solid cloud background, I might say. So, prerequisites. These are the items that need to be taken care of before the installation, which is Azure CLI to manage the Azure itself, kubectl for the Kubernetes, and RTF-CTL to install the RTF, and then use and access the RTF itself from your command line and get reports, get nodes status, etc. So let's move to the installing the Azure CLI first. So I'm using a MacBook, so I will be using the Homebrew. You can, if you are using Windows, there are some other options that you will install Azure CLI. I will be sharing it on the document as well. Also, kubectl you need to be installed, but for all these installation, I will be using the Homebrew. So, brew install Azure CLI. Yeah. Also, we will be using the RTF-CTL, installing of RTF-CTL here. but we will not be using the homebrew to install it. We just simply call an HTTP, so it will automatically install here. Brew install is almost complete. While it's deploying, let's go back to the architecture, and as you can see, we will have the nodes which should be, again, we will not be getting into much details, but before creating the Kubernetes itself, the cluster, you need to decide what do you need exactly about the sizing and also the node count. So how many applications will run on it, averagely, how many replicas you would like to run on it, how many vCores you're gonna use it. These information are valid and important for you to how that you will know that how many nodes or the size of the nodes will you need. Okay. After the installation of Azure CLI, then we will be installing the kubectl using again the homebrew. It will automatically bring, yeah, okay. Then we have all the command lines almost, and then I will be installing the RTF-CTL as well, so we can manage the RTF from here. After its installation, also it requires to give permission to it, so this is the next step. Okay, never run the first time. Okay, so I gave the permission as well. We also need the RTF license file as a prerequisite. So a MuleSoft account representative will help you to acquire an enterprise license in the form of license.lic file. So you also need that and make it ready while the deployment is happening. The next step is creating the cluster. So there are two ways there are two ways of creating the cluster. First, you can use the Azure portal UI, so you can go there and select next, or you can use the Azure CLI that we just installed to our machines. Let's go with the first one first, which is the Azure portal UI. I will not complete all it, just for the node I will be having that. So we go to, obviously, let's go back. You need a subscription over the portal.azure. When you come here, Azure, if it's the first time you are subscribed here, Azure will give you $200 credit for 1 month, so you can tinker around, you can check whatever you want. So we will be taking advantage of that. Actually, I am not, but you will probably. Then let's go to the Kubernetes services. You obviously will need a resource group. You can create from one here, or you can just select an old one. And due to this is merely a small test, so I will be going with dev test. But again, most probably you as a MuleSoft professional, you will not be the responsible of creating the cluster or applying the ingresses, etc. But this is for the general purpose and information. So you can at least implement of your own an RTF and run some applications over it without needing a cloud specialist help. So we can choose the dev test, optimize for cost, give it a name. I actually created a script and I will take the name from there so I can reuse the script. Okay, because it's and you can select the Kubernetes version. It can be above 1.20 anything, if I'm not mistaken. That was the thing. And you can also manage the size from here. We will be using DSV2. It's suggesting this is actually, it is wise because also MuleSoft suggesting that you need per node at least 16 gigs and 4 cores. But again, it will change with your requirements. It can be get higher or I don't think that the it will get lower, but this is the minimum. But we will go with DSV2. And you can select node counts for test purposes. I will selecting the minimum, which is 2, 1 for controller, 1 for the worker. And I will be leaving these as default for the time's sake. And you can come to the last part. Then you can just simply click to the create and it will be created. This is the first way. And the second way is actually creating it from the Azure CLI. To do that, first, obviously, you need to log into the Azure. So it will guide you to some website. Select your logged in credentials. Sorry. Come back here and we are logged into the Azure. So the next step will be creating the resource group. Since I had already created the resource group before, while we seen that the RTF test, I will be not doing that again, but I will be sharing the script with you. Yes, you can use the script. I'm just sharing in here. You can set the location in here, give a name of course obviously, and then just execute this command. After that, your resource group will be created. Take the name from there, and the next thing is that we're gonna create the actual Kubernetes cluster. So I will be getting the script. So in here, as we can see, our resource group RTF test, the name devo team RTF test, and the Kubernetes version, and we had chosen this almost the most smallest VM for this purpose. So execute that. You will be seeing that it's starting and running. Since this will take a little bit time, I will pause the video in here and jump to the ending. So our creation of the Kubernetes has been successfully completed. We can either observe from the UI, it has been created in here. Right now we can check that the created namespaces under there and have an overview here. Check the nodes, that we have already 2 nodes in here. So nonetheless, we can also check this from the CLI, but first we need to connect our Kubernetes. We need to configure our kubectl to connect to our Kubernetes cluster. In order to do that, we will be executing this script. So AKS get credentials, give the resource group and the name of the cluster. So yes, now we have the configuration for that. After that, again, if you want to verify that everything is smoothly going, that you don't want to get here and check that. Just call the nodes, get them here and see that the status are ready. And actually it has been some while that has been created. So our next step is creating the RTF on Anypoint platform. So there are several steps. So let's do it from the top. Get into the Anypoint platform from the main screen. Go to the runtime manager, and then runtime fabrics. Create a runtime fabric. Choose whichever cloud you're gonna use, or your bare metals, and give it a name like RTF test tutorial. Then it will be asking you to accept that about the support responsibility, which I had, if you remember, mentioned before in here. So MuleSoft takes seriously about that, because you will be responsible of the Kubernetes itself and the other tools that you're gonna use as an infrastructure. So let's get back to here, and we accept this responsibility. Then it will give us the activation code. Please keep this activation code, because actually this whole page displays the activation data used to install Runtime Fabric on a Kubernetes service. So we need to copy this activation code. If you must paste somewhere here, but we will be passing this one only once from the CLI again to be make it activated over the Azure Kubernetes. So we created the RTF test environment on the runtime manager. So we got the activation code here. So next step is to first validate the activation code. So in order to do that, we need to use rtfctl and do a validate command with the activation code you just copied. So paste it in here and execute the command. So it will take a little bit time, and in the end we will be seeing all validation successful, proceed with installation indications in here. It's also creating the containers right now. The validation operation actually verifies that the Kubernetes environment is running, all required components exist, and all required services are available. So all the validations are successful, proceed with installation. So the next step is to install the RTF. So again, we will be using the rtfctl install command with the activation code. So right now it is installing the RTF to the cluster. So in the output, we will be seeing again some kind of starting at the installing runtime fabric component, and at the end we should be seeing runtime fabric is ready. So after 66 seconds it has been installed. RTF is now online. Let's don't believe what I say, and let's check it. So we have installed the RTF. Actually we can see it from here, the status of it, and actually let's go to the runtime fabrics in here, and yes, we can now see that the RTF test tutorial has been active and the all systems are operational. And also we can see it here, everything seems good to go. But before finishing this, as the next step, we need to apply that which environment we would like to use. So check to the associated environments and check whichever environment you're gonna use. So I will be only apply this to the sandbox environment, then just basically click to the apply. After a while it will get applied, as you can see, and after this item we will be moving on with the actually applying the license. So without an as we had mentioned before in the prerequisites, you need a MuleSoft valid license key to be using this RTF. So in order to do that, by the way, if you don't have right now your license key, you can always access to the support portal and download it from there under the subscription section. To update the RTF with the license key, it should be on base 64 encoded. So in order to do that, you need to use a script, a command line again to the file, which will be changing your license keys into the base 64, and then you will be applying with this command line here, rtfctl apply mule license, and then your base 64 code. So I have completed applying the license. After you applied, you need to see something like that, so you will understand that your Mule license is updated. So we are almost ready to go. One last thing, of course, it's the ingress that we need to have HTTP calls to our applications. We need to apply an ingress controller. For this tutorial, we will be using one of the most common ingress controller, Nginx we'll be using. So there are all obviously other options that you can use. If you do not apply an ingress resource template to the cluster, we can add ingress endpoints when we deploy an application over Anypoint platform. So in order to apply, actually we will be using a ready to go ingress template in here. So I will be moving back to my terminal and paste that here. So we will be using kubectl apply blah blah, and it's right now applying. It already been there. So actually we can see the YAML file here. So we actually applied this YAML file. So this, as a result of applying this, it had created an ingress service there. Actually, there was another way that you can use. You can come here, and over the ingresses, you can simply add with the YAML and use the YAML in here. So it seems everything is for now okay. Let's move to the next step. So the next step is actually configuring what we had created just seconds before. So we need to configure the ingress controller. So we will be going with again with a template, with a basic template of your cloud team or anyone that will be responsible of the control of your environment for the ingress wise. So they will be actually applying. So for the tutorial purposes, we will be using this simple template. I had copied and pasted the YAML file here. I will be saving this to the documents as the ingress template.yaml. I'm copying this because I will be needing that in a second. Ingress template YAML. Yeah, okay. under the documents. So it is done. And the next step will be applying this template. So kubectl again apply f. We are actually over the path, so applying as this should be suffice. Okay, so the template has been created, as we can see. Now let's move to our Anypoint platform. No, sorry, we are already here. Come in there. So as you can see, there was nothing in here before. Right now we have rtf.example.com, which is we just pass it in the ingress template YAML. So that's why we can see that there. So every time we deploy an application, this has been shown in the ingress part. We will be seeing in the deploying the application. So we will be using this domain as an endpoint. So to the next step, we had actually applied this, and yeah, only thing that is deploying a Mule application we have left. So let's move back to the Anypoint platform. Also open here and okay. Now the next step is deploying an application. So we are in sandbox applications. It is like after you're installing the RTF, that you will be seeing this second option as the RTF tutorial that we just created. It will fill up basically. One of the advantages that you can use the RTF CPU as minimum as 0.02, which is great thing to do if you don't have so many processing power. And also you can allocate much more memory, not like in the Cloud Hub, but in here you can assign as much as unless your nodes obviously have the place to use that memory. As you remember, we had created a 7 gigs of nodes, and right now the remaining, because also there are running monitoring applications and the RTF agent, etc. So they are also consuming some memory there. So the available thing is only for now this, but you can increase this to 16 gigs, 32 gigs, 46 gigs, 64 gigs, etc. So let's move with a basic application. In order to that, let's call it, because it's an hello world application, yeah. So this is our application. Let's copy the name, and then we will be actually choosing from the exchange. Should we use the 4.4 version? I guess that will be not a problem. So from the application part, let's search for the hello world application under the example. Sorry, yep. Okay, this should be it. And minimum runtime version is there. Okay, since we are applying it to the Mule 4, we had chosen this and everything is here. So for the high availability, I mean while applying anything for the applications, you can select how many replicas. It is the same as while you are using the Cloud Hub. You can choose how many workers it should be running on. So you can choose in here how many replicas you would want to run them. Also, you can use persistent object stores, and after you select the tool, then you can run in the runtime cluster mode, which is they will be sharing a memory, and when one worker node had some kind of error, it will automatically continue with the other replicas. It's including any running process. So because it's sharing its memory, so you will not be losing any you will not be losing any data. If you even lose what have been processing, if you lose the node, but you will not be losing the data. So what we have done in the ingress part on the runtime fabric, we can see the resemblance in here as the host. We can see rtf.example.com. So, and it is actually a path, how can I say, it is a path based routing, so it has path in here as well. So this is the application name, so it will like slash and blah blah. But if you use a domain with wild certification, you will be seeing also an option here with the domain subdomain option. So you can actually put the app name as the subdomain, like I don't know, hello world devotmfct example.com. You can use something like that. So you can manage the reserved CPUs here, and your applications can burst when it needed. So you can align whatever CPU you want, and then deploy your application. Let's increase the memory a little bit. So we have place. Let's see 1.5. Okay. I'm not sure it will accept the comma. Okay. Then deploy the application. Okay, right now it's getting deployed. Right now we can see it's not running, still applying the configuration to the replicas. We will be seeing, after the first deployment of the application, we got the namespace. It's created after. Okay. So after it has been deployed, we will be seeing that we will get the Nginx. We will be getting the Nginx and IP of the Nginx server. Then we will be able to call the application. So after the okay. So both of the applications have been started. Right. Let's move to the command line again and get services and namespace. Okay, so we need to access to Nginx. So we will see the IPs of the Nginxes. Okay, so in here we can see the external IP that we will able to call the applications over that IP. Then let's do a curl call. Okay, so it's a bit long. It's a bit long item curl, so let me update it in here. Let's copy this IP. This is our IP right now, and the application name was FCT. Okay, nonetheless, let me copy this to be secure. Okay, this should call our application. It was RTF example, blah blah blah, port 80. Okay, let's see. Okay, the curl responded us with the hello world, which we are expecting. So yeah, we have completed our tutorial with the successful call of our application. Thank you for watching, and I will be sharing the document later for any party, or you can just mail me, so I will be providing the required documents or anything else. So thank you. It was a basic tutorial. There is too much to work on it, obviously, but it is good to see that from beginning to the end, creating all the RTF, creating the clusters, creating the RTF, deploying an application, and sees it's working. So yeah, thank you for watching again.